Have you ever heard about quantum physics and thought, that sounds completely bizarre? Particles existing in multiple places at once, behaving like both a wave and a solid object. It's a world where nothing seems certain, but then you look around. Your chair is in one spot. Your coffee mug is either on the table or it's not. So what's the deal? Why is the microscopic world so weird while our world seems so normal and predictable? The answer lies in a fascinating process called quantum decoherence. Let's start with a core quantum idea, superposition. This means a particle, like an electron, can exist in all its possible states at the same time until we measure it. Think of it like a spinning coin. While it's in the air, it's not heads or tails, it's a blend of both possibilities. Only when it lands or is measured does it pick one. This isn't just a theory. It's a proven reality for tiny particles. But you've never seen a cat that's both asleep and awake, right? So what stops this quantum weirdness from scaling up? This is where quantum decoherence comes in. Imagine a tiny quantum system in its delicate state of superposition. Now, picture it interacting with everything around it: air molecules, stray light particles, even tiny vibrations. This environment is like a constant noisy crowd. Every little interaction, every little bump leaks information about the quantum system out into the world. This constant interaction entangles the system with its surroundings, and that beautiful, fragile superposition starts to break down. The quantum system loses its special quantumness and starts to look just like a regular classical object. Think of it like trying to listen to a faint whisper in the middle of a rock concert. The whisper is the quantum state, and the concert is the environment. The noise is so overwhelming that the whisper gets completely lost. That's decoherence in a nutshell. To study quantum effects, scientists have to go to extreme lengths, creating vacuums and freezing particles to near absolute zero, just to quiet down the environmental noise. Outside the lab, this noise is everywhere, all the time. So decoherence doesn't erase quantum mechanics. Instead, it explains how the strange quantum probabilities transition into the definite outcomes we see every day. The countless possibilities of a superposition state don't just vanish. They get scrambled by the environment so that only one stable classical reality emerges. For large objects, which are made of trillions upon trillions of particles, this happens incredibly fast, way faster than the blink of an eye. That's why your chair is always just a chair in one single place. Its quantum nature is being constantly decohered by its interactions with the world. This idea even changes how we think about measurement. Early on, some thought a conscious observer was needed to collapse a quantum state. But decoherence suggests the environment itself is the observer. The constant interaction with the outside world effectively measures the system, forcing it to settle on a single outcome long before we ever look at it. Understanding decoherence is also vital for the future. It's the biggest villain for engineers building quantum computers. These incredible machines rely on keeping quantum bits, or qubits, in a state of superposition. But any stray interaction from the environment can cause decoherence and destroy the calculation. Figuring out how to shield qubits from this environmental noise is one of the greatest challenges in modern physics. Ultimately, decoherence provides the missing link between the quantum and classical worlds. Our everyday reality isn't separate from quantum physics. It's an emergent property of it. The stable, predictable world we see is born from countless chaotic quantum interactions happening every single moment. The bizarre rules of the quantum realm aren't gone. They're just hidden in plain sight, masterfully concealed by the constant dance of decoherence. Thanks for watching, and if you enjoyed this journey into the quantum world, be sure to like and subscribe for more.